3 customers arrive at an automated teller machine every 15 minutes. We can assume Poisson arrivals. Several questions to be answered. Notice in this problem, it says every 15 minutes the average arrival is 3 customers. Actually, over here I should say average of 3 customers arrive at an automated teller machine every 15 minutes. So the 3 customers arriving is for a 15-minute period. So in answering all these questions, we need to be mindful of the interval of time that the question is asking about. In the first question, it's asking about every 15 minutes, but in the second question, it's asking about 30 minutes. In the third question, it's asking about an hour, and then again, it's 30 minutes here, 15 minutes here, and 1 hour here. So we need to be careful of how we perform our calculations. In fact, that mu, or average number, must be adjusted for the interval that we're solving. Let's start by creating our probability distribution. The probability will be Poisson distribution, so Poisson dot dist. X is whatever the value is for the random variable. So in this case, to compute probability of 0, I would put probability of A12. Mean is this is for, let's compute a column for 15 minutes. So mean is 3 for a 15-minute interval, and I do not want cumulative probability, so I want the probability of exact values reported in this column. So I will put 0 for false, or I can just write false. And this would be for a 15-minute interval. So I can do the same for a 30-minute interval. Notice that for a 30-minute interval, my mu is going to have to be 6. Because if 3 people arrive in 15 minutes, then in 30 minutes, which is twice as long, 6 people would arrive. So I would make the same calculations, but my mu would be different. Now mu, or mean, is going to be 6. And again, I do not want cumulative probabilities. I want the probability of exact value. So I can put either 0 here, or I can put false. I can do the same thing for 60-minute interval. Again, the X value is in column A. Mean now would be 4 times 3, or 12, for a 1 hour period, because there are 4 15-minute intervals in 1 hour, so 4 times 3 would be 12. And again, I want to say false. If I copy that down, now I have all these numbers. So I can use all of this to answer these questions. Probability that exactly 6 people arrive in 15 minutes would be, for a 15-minute, exactly 6 would be this number. probability that exactly 5 people arrive in 30 minutes. So this would be equal to, for a 30-minute interval, exactly 6 would be this one. Probability that exactly 5, oops, I've been doing 6, but I should have been doing 5. It says probability that exactly 5. So let me change these. Equals exactly 5. Equals exactly 5 for a 30-minute. Okay. Now probability that exactly 5 arrive in 1 hour. That would be over here. Probability that at least 4 arrive in 30 minutes equals exactly that at least 4 arrive. So this is the sum of at least 4 arrive in 30 minutes. So here's the 30-minute column. At least 4 means 4 or more. So I can either say summation of all of this or I can say equals 1, or I can say equals 1 minus the summation of 0, 1, 2, and 3. And either way, you should get the same answer. Or I can just say equals 1 minus Poisson distribution, where x is 3, mean is 6 for a 30-minute interval, and I wanted cumulative, so I would say true. And either way, I'm going to get that. So I would compute the probability of Poisson distribution cumulative up to 3, which would mean 0, 1, 2, and 3. Whatever that is, I subtract it from 1. And so there are many ways that you can solve the same problem. Here, no more than 8. No more than 8 means, for a 15-minute interval, would mean summation of, using the first column, no more than 8 means 0 to 8. So 0 to 8, and I can use the cumulative probability, Poisson dist. No more than 8 means 8 or less. So 8 comma, for a 15-minute interval, that would be 3. The mean would be 3. And I wanted cumulative, so I can put either 1 here or I can put true. Either way, it would get the same. I would get the same answer. And finally, less than 20 arrive in 1 hour. So here is this column with 60 minutes. So 1 hour is 60 minutes. So this equals summation of less than 20. So less than 20 would be summation of 0 to 19. And less than 20, I can use the cumulative function equals Poisson distribution of less than 20 would be 19, so I would put 19. The mean would be 12, and cumulative would be true, or I can put 1 for it, either way. So that's how you solve these problems. Thank you.